Good evening, guys. I received this problem and they wanted the solution as well as the explanation to the solution. So this is from the biostatistics. The question was about the assessing serum cholesterol levels in the diabetic patients, the analysis and the implications. So how was the question presented to them? Well, how many diabetic patients from a study would be expected to have their serum cholesterol levels exceeding 230 milligram per deciliter? The study evaluated the serum cholesterol levels of 200 patients with diabetes mellitus, means they have diabetes. These are those patients who were diabetic and their serum cholesterol level was evaluated. 200 patients, finding that the results followed a normal distribution with a mean of 220 milligram per deciliter and a standard deviation of 10 milligram per deciliter. So this is the mean and this is the standard deviation. This information is approximate. So on the graph, we can see that this curve, this is the normal curve. The normal distribution curve representing serum cholesterol levels with a mean of 220. This is the mean, 220 milligram per deciliter. And a standard deviation of 10 milligram per deciliter. The x-axis, this one, shows the serum cholesterol levels, 220, 230, 240, 50, and 60. The y-axis, it represents the probability density. Like, say, for instance, this. So what would be the probability density? So let's start analyzing it. The given parameters are the mean, that is mu, it is 220 milligram per deciliter. And the standard deviation, which is sigma, that is 10 milligram per deciliter. Remember these figures now. The question is asking about the probability that a patient's serum cholesterol level is greater than 230 milligram per deciliter. Almost less than 200 milligram per deciliter is desirable level. 200 to 239 milligram per deciliter is borderline high level. And 240 milligram per deciliter and above it is considered as high level. First of all, we will calculate the Z score. And this is the step one in this calculation, in this analysis. Z score formula is X minus mu divided by sigma. Well, X is 230 milligram. That is the observed value, 230 milligram per deciliter. Mu was, that is the average, it was 220. And sigma was standard deviation 10. So calculating it, we will receive the answer 1. Our Z score is 1 or Z value is 1. What is this Z score? Z score is a way to figure out how far away a piece of data is from the average of a group measured in standard deviations. It tells us if a data point is typical or unusual compared to the rest of the group, which is useful for spotting unusual values and comparing data between different groups. So Z is 1. This is the Z score table. Finding the probability corresponding to this Z score on the Z score table. The Z table gives the probability that its value is less than a given Z score. For Z1, Z which is equal to 1, the probability is 0.84134. So we have tabulated it over here. This means that about 84.13% of the values, they are lying below 230 milligram per deciliter. Calculating the probability of serum cholesterol greater than 230 milligram per deciliter. So this is the formula, and that is Px greater than 230 is equal to 1 minus P, that is probability, Z less than 1. And here we have this value, 1, corresponding to that was 0.8413. So if we will apply this formula, this is the value which we will get, 0.1587. The total number of patients in the study were 200. The expected number of patients with a serum cholesterol level greater than 230 milligram deciliter is that 0.1587, which we have calculated on the previous slide, multiply by 200. So our answer is 31.74, which is almost equal to 32. Our conclusion is approximately 32 patients are expected to have a serum cholesterol level greater than 230 milligram per deciliter. The options provided, because it was a multiple choice question, so A, 16, B, 32, C, 84, D, 95. The correct answer is option B, that is 32 patients. They were expected to have a serum cholesterol level greater than 230 milligram per deciliter. Thank you very much. And whenever you will be sending me some more questions on biostatistics, I will try to solve those like this and explain these, and I will present it to you. Thank you very much. Goodbye till then.